Hello and welcome to another video. We have a 3-in-1 question on the board. In triangle ABC, prove Roman numeral 1. Okay, to prove that in triangle ABC, okay, side A sine parenthesis 1/2 of angle A plus angle B will be equals to parenthesis side B plus side C multiplied by sine 1/2 of angle A. Okay, now first we need to understand that the left hand side is equals to the right hand side. So I can start from the left hand side. Okay, now left hand side is equals to A sine parenthesis 1/2 of angle A plus angle B. Okay, now we are given that in triangle ABC, so I'm going to use the angle sum property. That is, we have triangle ABC using the angle sum property. Okay, using the angle sum property of triangle. So we have that the sum of interior angles in a triangle is equals to 180 or 1 pi. So which means A plus B plus C will be equals to 180 degrees or 1 pi. So now, remember, I want to prove the left hand side. Okay, so we have A sine parenthesis 1/2 of A plus B. So now let's say angle A is equals to 180 minus sum of angle B and angle C. So it means that A sine parenthesis, now let's say we have this to be A plus 2B, okay, over 2. That is if you simplify this, okay, then this will be A sine parenthesis, now A is 180 minus parenthesis B plus C, okay, plus 2B, okay, all over 2. So that A sine parenthesis, now if we open the parenthesis, okay, distributing the minus in this case, we're going to have 2B minus B. That will be 1B. So this will be 180 plus B. Then this will be minus C, because minus times plus, that will be minus. Then divided by 2. Okay, so that this will be A sine. So I'm going to divide this. This will be 90 plus B minus C over 2. Now, it should be noted that sine 90 plus B minus C over 2 is equals to cos, because this will be in the first, so this will be, then it will be equals to cos B minus C over 2. B minus C over 2. So which means that A sine parenthesis 90 plus B minus C over 2 will be A cos B minus C over 2. So this is the left hand side. So this is equals to the left hand side. Now, for the right hand side, we have parenthesis side B plus side C multiplied by sine 1/2 of angle A. Now what I will do in this case is I'm going to use Sinerule. Okay, I'm going to use the Sinerule. So I'm going to use the Sinerule to express B in terms of sine B, and that's 2r. Okay, that is the r represents radius of circumscribed circle. Okay, and we say that from Sinerule, we have, since we have B and C, so in this case I'm going to use B over sine B equals to C over sine C equals to 2r. So it means that B will be equals to 2r sine B okay, and C will be equals to 2R sine C. So I'm going to substitute 2R sine B and 2R sine C for B and C, okay, in this expression. So, which means we're going to have 2R sine B plus 2R sine C, okay, multiplied by sine 1/2 of A, 1/2 of angle A. Now 2R is common, so I'll factor out 2R. So this will be 2R parentheses sine B plus sine C multiplied by sine 1/2 of angle A. So now I can use the sum to product identity for sine B plus sine C. Okay, using the sum to product identity, okay, for sine B plus sine C. Now sine B plus sine C will be 2 sine B plus C over 2, then cos B minus C over 2. That's the sum to product identity for sine B plus sine C. All right, so it means that this will be 2R, this will be 2R, okay, 2R multiplied by 2 sine B plus C over 2, then cos B minus C over 2, then multiply by sine 1/2 of A, multiply by sine 1/2 of A. Okay, so now let's also recall from here that we know that A is equals to 180 minus sum of B and C. So it means that B plus C, okay, if I make B plus C the subject of the formula from here, B plus C will be equals to 180 minus A. So this will be 2R parentheses 2 sine 180 minus A divided by 2. Then I'm going to switch, I'm going to take this outside and bring this inside the parentheses. So this will be sine 1/2 of A, then multiply by cos B minus C over 2. Now in this case, this will be 2R, okay, 2R, open square bracket, 2 sine, this will be 90 minus A over 2, okay, then multiply by sine 1/2 of A, multiply by cos B minus C over 2. Now sine 90 minus A over 2 will be cos A over 2, yeah. Now 2R, now, okay, like I said, sine 90 minus A over 2 is equals to cos 1/2 of A. So it means that we're going to have that the right hand side will be equals to, let me just write it this way, 2R, okay, 2R multiplied by square bracket 2 cos 1/2 of A sine 1/2 of A, then multiply by cos B minus C over 2. Okay, so now we have cos 2 cos 1/2 of A multiplied by sine 1/2 of A. That is the half angle formula for sine A. Okay, that is sine A is equals to 2 sine A over 2 cos A over 2, and that's what we have here. So which means 2 cos 1/2 of A sine 1/2 of A will be equals to sine A. So that 2R multiplied by this, that will be sine A. Okay, then multiply by cos B minus C over 2. This is still the right hand side. So we can say that the right hand side is equals to 2R 2r sine A, okay, cos B minus C over 2. Cos B minus C over 2. Now, and then we know that 2r sine A using the sine rule, okay, if you are using the sine rule, that is, if I use A over sine A to be equals to 2r, okay, so it means that A will be equals to 2r sine A. So which means 2r sine A will be A, that is lowercase letter a. So it means that the right hand side will be equals to A cos B minus C over 2. So this is the right hand side. Then we have the left hand side to be, this is the left hand side. So the left hand side is A cos parenthesis B minus C over 2. Right hand side is A cos parenthesis, that is A cos parenthesis B minus C over 2. So therefore, left hand side is equivalent to the what? Is equivalent to the right hand side. And that's the first question. Now, Roman numeral 2. Okay, I'm going to make this one short because, yeah, for Roman numeral 2, we want to prove that the product of side B plus C minus A, okay, and parenthesis cot 1/2 of B plus cot 1/2 of C will it be equals to 2 cot 1/2 of A. I'm going to make this one short, okay. Now what I will do in this case is I'm going to use the formula for semi-perimeter. Now we know that semi-perimeter, for those of us who are familiar with the Arrow's formula, okay, now semi-perimeter is S equals to the sum of the three sides of a triangle divided by 2. So if we have parenthesis B plus C minus A, now for this one, now we know that from here, 2S will be equals to A plus B plus C. So which means that A plus B plus C minus 2A, okay, will be equals to B plus C minus A. So which means that because we know that A plus B plus C is equals to 2S, so then I can say that 2S minus 2A, okay, is equals to B plus C minus A. Okay, now cot 1/2 of B, that will be square root of the product of semi-perimeter. That if you have cos 1/2 of B, the formula for this is square root of the product of semi-perimeter and semi-perimeter minus, this is B, okay, over S minus A, then S minus C. Then same with cot 1/2 of C. Now, for those of us that we are expecting, that I'll use the formula for that. I'll use the one I introduced just now. That is cot 1/2 of B equals to that. Okay. Now it's going to what? It will be time consuming to be able to prove the identity on the board. That's the Roman numeral 2. So what I will do is I'm going to use the formula for in radius. I'll use the in radius formula, that cot 1/2 of B, that will be equals to S minus B over R, and also cot 1/2 of C, okay, 1/2 of C, that will be equals to S minus C over R. Let's not forget that S represents the semi-perimeter. Okay, so we have that the left hand side for Roman numeral 2, we have the left hand side to be the sum of side B, side C minus side A multiplied by cot 1/2 of B plus cot 1/2 of C. Will it be equals to 2A cot 1/2 of A? Okay, now let's note this. Cot 1/2 of A will be S minus A over R, which is the in radius formula for, that's a half angle formula for cotangent. All right, so in this case, so we already know that B plus C minus A is 2S minus 2A. So this will be 2S minus 2A. Then multiply by, now, Cot⁴ of B, that is the in radius formula for half angle formula for cotangent, okay? We have that to be S minus B over R, then plus, okay, plus, this will be S minus C over R, okay? So we can add this together. We add this together. So this is, let me factor out 2 in this case. So we have 2 parentheses S minus A, then multiply by, so when we add this together, this will be S minus B plus S minus C, okay? S minus B plus S minus C over R, common denominator, so that this will be 2S, okay? So we have 2 parentheses S minus A multiplied by 2S minus B, then minus C over R, Now, this is very important. Now, we have 2S minus B minus A. 2S, we have S to be equals to A plus B plus C over 2. And that means 2S minus B minus C. That will be equals to A from here. Okay, so which means that this will be A. It will be equals to side A. So we have 2 parentheses S minus A multiplied by A over R. Okay, now let me rearrange this. This will be 2A, okay, 2A, then parentheses S minus A over R. Remember I said the in radius formula for Cot⁴ of A is what? S minus A over R. So which means that, from here we have that this will be 2A Cot⁴ of A, and this is what we're looking for. This is what we're trying to prove. So which means that the product of side B plus C minus A and the sum of Cot⁴ of B plus the sum of Cot⁴ of B and Cot⁴ of C will be 2A Cot⁴ of A. And that's the second question. Okay, so for Roman numeral 3, Roman numeral 3, we have Roman numeral 3. Okay, this is Roman numeral 3. Roman numeral 3, to prove that the product of parentheses A squared minus B squared plus C squared tan B is equals to the product of parentheses A squared plus B squared minus C squared tan C. Okay, now this is very simple. Okay, now let's go back to cosine. Okay, from cosine rule, okay, if we have A squared plus C squared, okay, minus B squared, this will be equals to 2AC, okay, cos B. Okay, if you are familiar with the cosine rule formula, okay, then also on the right hand side we have A squared plus B squared minus C squared. So this will be 2AB cos C. That is the cosine rule formula. Okay, all right, so which means that then also from the definition for tangent, tan B will be equals to sine B, okay, over cos B. And also tan C will be equals to sine C over cos C. So now we have that the left hand side is equals to the right hand side. Okay, so now from the left hand side we have parentheses a squared minus b squared plus c squared multiplied by tan B. Okay, and that is 2ac 2ac cos B, then multiply by tan B, which is sine B over cos B. Okay, I don't want to do it one after the other. I want to do it together. So this is the left hand side. Now for the right hand side, we have a squared plus b squared minus c squared to be 2ab cos C, then multiply by, we have tan C, which is sine C over cos C. Cos C will cancel cos C. Cos B will cancel cos B. So then we have 2ac sine B to be equals to, this will be 2ab sine C. Now 2a is common, okay? We have 2a square bracket, 2a square bracket C sine B, okay, equals to, we have 2a also to be common on the right hand side. That will be 2a square bracket B sine C. Okay, so if you divide both sides by 2a, divide both sides by 2a, we're going to have the left hand side to be C sine B and the right hand side to be B sine C. Okay, B sine C. Now let's go back to the sine rule. Okay, now we know that from sine rule, if I have B over sine B equals to C over sine C, if you cross multiply, this will be B sine C, that is lowercase letter b, sine C, higher case letter C, then lowercase letter c multiplied by sine B. So which means that from what we have here, C sine B is equals to B sine C. And this is how to prove that the product of a squared minus b squared plus c squared tan B is equals to a squared plus b squared minus c squared tan C. The noblest pleasure is the joy of understanding. Bye-bye.